welcome to the Debugging Cloud Applications at Scale talk. I think the name wasn't exactly that, it's close. My name is Patrick Flynn. I'm the Java Tools Tech Lead on GCP, Google Cloud Platform. And today we're basically going to develop and deploy an application on GCP and then find an issue with it and debug that in the cloud. So this is a picture from the good old days, right? I don't know how long you guys have been in the business, but when I started out, it was back in 2003, hardware was very manual, and when you wanted to provision your hardware for when you're ready to go to production, you typically had to fill out a purchase order, work with some people in the organization, and wait 6 months, a year for some machines to be somewhere for you to actually be able to deploy your software. This is actually a picture of one of Google's first racks after Google became a private company. And they actually used corkboard to separate the motherboards. This is actually worse than the first racks that I worked with, which is kind of surprising given Google's reputation. But it was cheap, and Google was a scrappy company. So that wasn't the only bad thing about developing Java applications in the olden days. The other issue was that the tooling really wasn't where it is today. Typically, deployments are like a manual thing. Actually, let me ask you, how many of you guys are actually developing backends on Java right now? How many of you do your provisioning of, let's say, configuring your production environments by hand, where you actually set up the operating system, install the application server? No. We've got a couple over here. Yeah, I'm not surprised, right? And probably the same people might be doing the deployments by hand as well, right? Once you start scaling, that's really tedious and error-prone, right? Today, we have better options, right? From the infrastructure point of view, you can actually provision hardware in a matter of seconds that you didn't even know that you needed the day before. You can benefit from like fantastic physical security for your machines, great network infrastructure, always up to date from a hardware refresh point of view. But even if you do go cloud, if you're still configuring your machines yourself and deploying manually, you haven't really gotten all the benefits out of the state-of-the-art in Java tooling today. So I'm going to cut to the demo and give you an idea of how you might run and deploy an application at scale on GCP. Show of hands again. How many of you know what Spring Boot is? Yeah, from what I hear, this is the platform of choice in the community right now. So what we have here is basically a REST controller. It's actually almost a carbon copy of the Getting Started Spring Boot app with a few endpoints added to it. Oh, whoops, oh, I forgot something. My notes. So one of the cool things about, well, I guess if you care about this kind of thing, about a Spring Boot app is that typically you deploy these as jars, not wars, right? Make jar, not war is the joke that I hear often about this. And what that gives you is an application container embedded into your binary versus you having to make sure that your deployment environment is as you wish it to be. So that's pretty cool, right? But it's still a little bit of a hassle to configure your actual machines to have the environment set up to be on the right version of the operating system that you want, right? So let me just run this locally real quick. I wish I had a little bit more space up here. if you guys can see, I'm just going to zoom in. Yeah, I know. So this is really like high res. So I've zoomed in like the actual text, but I guess I could change the resolution. Or is this fine if I just kind of zoom in like here?
As long as you can.
Okay. All right, so I'm going to do the local run. Another show of hands. How many of you use IntelliJ? That's great to see. So we actually have Eclipse and IntelliJ plugins for the Google Cloud Platform. What I'm showing you here is not one of our features. What I'm showing you is basically the built-in IntelliJ Enterprise Edition Spring Boot support. So when you import a Spring Boot project, it'll automatically create a run configuration for you. I'm going to go ahead and fire that up. And you see that the app is being built, and in a second, it's going to come up. So here we go. Let's have a look at a few of the endpoints I have. I've got a really simple hello world that tells us what version of the application this is. And I have a visit endpoint that does something pretty dumb. It takes data store, which is a automatically horizontally scaling database that Google Cloud Platform offers our users. It creates an entity with the current time in milliseconds, saves it, reads it, and then displays it. So let's actually try hitting that endpoint. So localhost 8080. So here you can see, let me zoom in a little bit. This is the hello world. Then we have the visit endpoint. And this visit endpoint is actually reading and writing to data store in the cloud from my local machine. So I find that endpoint to be pretty boring. Like, how could we jazz it up, right? There's some pretty interesting APIs that Google Cloud offers. What would be the workflow for me to actually start using one? One really neat way that I could make this more interesting is if I just somehow magically translated the text that I'm displaying to the end user. So how do you do that? Let's see. The first thing that you need to do is, I was in the right place, is open up your POM XML and add the dependency that's required for that. So I'm going to add com Google Cloud, which is a namespace for all of our APIs that are on GitHub, and the Google Cloud Translate API. We're going to pick 0.9.4 alpha. And now IntelliJ automatically adds that dependency to the class path of the project. If I go back to the demo controller, I should be able to create a I believe it is this one. So we'll create a translate service. I think it's this one. And now translating the content is as simple as calling translate dot string, and then, let's see, translate options. It might not be options. Let's actually look up the API real quick. So you can find in our documentation site instructions on how to use, wait, I believe this is a Java doc sample. Not what I was looking for. Right, so if you look here, we can quickly find how to select a source language. So we get translate option dot source language. So it's not options, it's just option. In this case, it's English. And the next parameter is the target language. Let's see. I guess because we've got Ludo in the house, maybe we'll pick French. And the next parameter is, am I using this API correctly? Oh, maybe not. What? Look real quick. We've got, okay, so the string goes at the front. So let's just grab this message. First parameter, pass it in, and get rid of this line of code right here. And we need to return the actual translated text. So do you guys think this is going to work? I'm not sure after all that kind of hacking away. Let's give it a try. So close this out, refresh. Wait, I probably need to restart my server. Let's go ahead and do that. Spring Boot actually, with the DevTools imported, will reload on build, but I wasn't sure if it would do that with a dependency change, so I went ahead and just restarted the whole thing. There we go. Bienvenue sur Java Tools Demo. That's actually a pretty good translation. Yeah, I like that. But actually, let me go back to the API, because I saw something that was pretty kind of cool looking. I think I saw that you could detect the language. Let's try that again. No, not this guy. Where was the code? Here. Translate, and there's translate.detect, right? So if we go here and do translate.detect, we can actually pass in a string and get a source or a target language. So let's try doing that by actually just adding a parameter to our endpoint. So call it greeting. Add a path variable. So Spring Boot is really popular because it's really easy to manipulate your API and do these kind of things. So we'll call it, I guess it's just a string called greeting. And we want to detect what language it is. What does that return us? A language. So let's go ahead and take that. And make it the target language. And if I just do a build, did that do a build? No, here we go. If I do a build, we should see Spring restarting itself. And let's see if that worked. So this page is not what you were looking for because I've changed the URI. It's actually visit plus some greeting. We're going to say, actually, let's pick a language. Hello in Japanese. I knew what this was, of course, but typing that into my keyboard is not easy. And let's just add that here and see if this works. There you go. Japanese response to a Japanese greeting. Yeah, that's pretty cool, right? So I kind of love this feature. So I want to get it out to my users as soon as possible. So the next step is, let's go ahead and commit this. So by the way, I forgot to mention, the Google Cloud Tools for IntelliJ has a bunch of support for various Google Cloud services. Let me zoom in here. If you guys ever have trouble not with seeing something, just let me know. We have the standard App Engine support that used to be available in IntelliJ Ultimate that we ported over into our plugin that's also available in Community now, except for running local dev server because those bits aren't available in Community for us to use. We support deploying to App Engine Standard and Flex, using the Stackdriver Debugger, which we're going to talk about a little bit later, and cloud source repository integration. So with every Google Cloud project, you get cloud source repositories that you can basically create. I'm not sure if there's a limit, but a ton of cloud source repositories within that project. And then you can both check out and import into your cloud source repositories from IntelliJ. So what we're going to do is we're going to deploy this app engine. So now I have a few things I need to figure out, right? This is our deployment UI. The first most important thing I need to decide is what am I actually trying to deploy. We support either a file system jar or war, the IntelliJ artifact system. So if you guys are familiar with IntelliJ and you are in Ultimate and you import a web project, it'll automatically generate a war artifact for you. And we also will inspect, if it's a Maven project, what the Maven build output is and allow you to select that as your deployment source, which is actually probably the best thing to select because your build might actually be customized in some ways through, go ahead.
What do I do if I'm a Gradle person?
So if you're a Gradle person, that's an excellent question. We support you in the sense that you can do your build in Gradle and then you can select your deployment target. We're working on trying to figure out exactly what so we have some support for inspecting the Gradle build, but it's more difficult to identify the exact build artifact that you might want to actually deploy. So we don't support it for now. So here I'm going to select the project I want to deploy to. If you're not familiar with Google Cloud Platform, a project is basically a context, right? The networks are separated. Everything is sort of an isolated cloud environment, right? So I'm selecting Java Tools DevOps. We've detected that the App Engine region of this project is US Central. And we tell you here that the App Engine environment is going to be flexible. And the reason for that is because you don't have an App Engine Web XML. If you're not familiar with App Engine Standard, you need an App Engine Web XML for it to be an App Engine Standard app. And over here, we're going to override the version. Typically, the Cloud SDK, which is the Google Cloud Platform SDK that you need to install locally to interact with the Google Cloud Platform from the console, will generate a timestamp version when you do a deployment. We're going to actually just pick a version that we want, right? So we're going to call it 6.0. And we are not going to promote this version. I'm going to talk about what promotion means in a minute. Right, so and finally, the last thing is configuration. So what this is about really is App Engine flexible environment is two things. The first thing is it's a really easy way to take your Java or Python or Ruby app, I think Ruby, and deploy it to App Engine Flex without really understanding the underlying infrastructure that's running your application. But the flexible product wants to give you control so that you can customize your environment. That's part of the allure of Flex, is that it lets you install native dependencies and things like that. And it does that by making the deployment unit a container. So if you select custom, you can actually specify, let's say, a Docker file and app-YAML configurations that determine various different things. So, but for now, I'm going to leave it at auto and go ahead and run that. So what we'll do is we'll, oh wait, did I? No, I didn't, hold on. Is there a way to cancel this? Probably not. Well, it's fine. I'm going to do it in Kubernetes later, so don't worry about it. What I wanted to do was commit to my project repository, because it's a really bad practice to deploy to production when the code is not actually in a source repository. But we're going to ignore that I did that, because this is a demo. And so what's going on, right? We built the Maven artifact. Now what are we doing? Well, because this is container-based, what we're doing is we're orchestrating a Docker build that's going to happen for you in the cloud. You don't need Docker on your local machine. You don't need to know what Docker is. But we'll look at the deployment target, which in this case is a jar, and decide, well, this is probably something that we'd want to run on an OpenJDK 8 runtime. So we take that a Docker-based image that's pre-configured to run well on Flex, add your jar, and then build that in the cloud. So that's what's happening right now. It's a little slower. I don't know if you're familiar with App Engine Standard, but if you do a deployment in App Engine Standard, it happens incredibly fast because you're deploying to shared resources. In App Engine Flex, the underlying infrastructure that's actually running your app is like basic GCP infrastructure. So GCE instances are actually running the code, so they need to be provisioned. Load balancers need to be brought up, that kind of thing. So I know what you're thinking, right? Well, maybe a couple of you are thinking. App Engine is this proprietary Google technology. I'm not really interested in being locked in to App Engine. That's an important concern, right? This App Engine Flex is not this. It's not a walled garden, right? The reason is because the APIs that you saw me use don't require that you run in the App Engine Flex environment for those APIs to be usable. You saw me run those locally, and they work just as well, right? The base unit of binary that you're running is a Docker image that you can take and run somewhere else as long as it runs Docker containers, right? So really what App Engine Flex is more like a road, a path that is laid for you where you don't have to make too many decisions, but if you want to stray off, there's nothing stopping you from doing that. So I'm actually going to show you how to do that. First, how many of you guys know what Docker is for a start? That's what I was hoping to see. And how many of you guys have heard of Kubernetes before? All right, so if you're not running your Docker images on App Engine or some other proprietary Docker image orchestration system, you're probably going to be running them in Kubernetes or Docker Swarm, right? So where does Kubernetes come from? At Google, we've been running containers for, I think, decades. Well, definitely decades. And we needed a system because we run at really large scale. And we built Borg, which is a precursor to Kubernetes. Kubernetes was informed by the design of Borg and open source, and now has really gained a lot of community adoption. So what we're going to do is take the application that we just deployed to App Engine Flex and deploy it to Kubernetes, right? So how does one do that? Well, the first thing you need is a Kubernetes cluster to target. So let me go ahead and create one. So gcloud, I mentioned the Google Cloud SDK a little earlier. gcloud is a CLI that gets installed when you install the Google Cloud SDK. So we're going to gcloud compute container is the subcommands related to containers, clusters, create, we'll call it demo app, and we have to add scopes to our instances so that they can talk to the various APIs like data store, cloud debugger, and Google Translate. And that, I believe, is called Cloud Platform, which kind of gives you an aggregate of all of those. So we'll actually start that off. Now what this is going to do, it takes around 4 minutes, is sort of bring up a lot of the same infrastructure that App Engine Flex is doing, but in a way that the Kubernetes master can target. Okay? So, okay, never mind. So how am I going to take this same app and deploy it to Kubernetes? The first thing I need to do is create a Docker file so that I can actually create a container and deploy it. Another thing that I could have done is taken the App Engine Flex container, which you can find in Google Container Repository, which I'm going to talk about later. But here what we have is a plain vanilla Docker registry-based OpenJDK8 runtime that's, oh yeah, I'm sorry. Let me zoom in. What's going on here? There we go. Okay, so it's OpenJDK base. It's gonna listen on 8080. And what am I doing here for the run wget? This is basically how we configure the Cloud Debugger to work in an environment other than App Engine, where we've actually configured this for you. So we need to download the Cloud Debugger agent and then configure it, as you see over here, in the Java agent path invocation. By the way, the Cloud Debugger agent for Java is on GitHub and open source. So that's really cool because it means that the Cloud Debugger is just this open source agent talking to a Google Cloud Platform debugger service that you can run those jobs anywhere, and all the different pieces of the Google Cloud Platform that used to be siloed and monolithic part of the App Engine standard environment, you can now consume those as independent pieces, right? So that gives you a lot of flexibility as a user. The last thing I want to point out about the Docker file is when you're running an App Engine, there's a model. But when you're running in Kubernetes, you basically just have the service model. What we want to be able to do with the Cloud Debugger is identify the job that is running the same kind of binary so that when we have an issue in production, we can listen to all of those different jobs running at the same time. So what I've done here is basically filtered into the Docker file the service name and the project version so that when I build the image, the agent reports, the agents that are all running as part of the same job are all reporting the same key to the Cloud Debugger master. Whoops. Okay. So the next thing that I need to do is make sure that I build this Docker image, right? Actually, let me go ahead and commit this. So add awesome let me zoom in. Add awesome translations. And zoom out. Commit and push. All right, so that's pushing up into GitHub, which is another really cool thing. Because if you're an enterprise, you might not want to have your source on Google Cloud, right? That might, you might want to have your private GitHub repo, or maybe your own Git repo that you know nobody else has access to, right? If you're using IntelliJ to do your diagnosis, you can actually do that. Okay, so this is our POM, right? What's special about it now that allows me to build Docker containers? The first thing that you'll notice is that I've configured the Docker file to be filtered by Maven resources. And I put that in a directory. Let me zoom in a little bit. I've created this Docker ready directory, which is going to be where the staged filtered Docker file is put in the target directory. And then I'm using the Spotify plugin, which is a really popular Maven plugin for Java users to build Docker images. There's a couple of them. This is the basic one that just kind of follows a Docker model where you specify your Docker directory that has a Docker file, specify what your image name is going to be, what to include in the Docker directory, and it'll just call Docker build on that. And then the next thing that you need to do is actually, if you want the Cloud Debugger to work, is make sure that you package in source context. So source context is a way that we understand what version of the code is running in production. If you use Spring Boot will generate a get.properties file, and that is source context. We actually have a build of the Cloud Debugger agent that supports that. It's just not available to end users yet. So to get around that, you can actually just use the native source context file that Cloud Debugger supports. All right, and then finally what you need to do is actually push the Docker file to a Docker repository. And this is basically the way that you can do it with gcloud. With just like we provide a cloud source repository with every Google Cloud Platform project, Google provides a container registry with every Google Cloud Platform project that is private to you. So if you are an enterprise and you want to actually push Docker images, maybe you don't have a Docker Hub account, you don't want to push public images, you can now do that using a Google Cloud Platform really easily, and that's free. Okay, so let's actually let's go ahead and do that. But one thing that I'll point out is that I've bound pushing to our container registry to the deploy phase. So I'm going to go, instead of deploying the way we saw earlier, I'm going to go ahead and deploy from a machine that is not my development machine, so that I know that the source, it hasn't been modified. So I can do git pull. Am I in the right place? Let's just make sure. Should work. Okay. What branch am I on? What do I have here? Do you think? Sure. What is? Well, this is not the right version because we've pushed a version that has. Oh, this is my. Hold on, cat. Oh, that's right. So the version master should be. This is kplay. If I go look on GitHub, it should be Java Tools DevOps. Java Tools DevOps, right? I'm not going crazy here. So why is it trying to change?
Oh, you made that change also locally there.
Well, let's just get reset Borg. Right. Is it?
Minus mark.
I thought so. Yeah, using Git in front of a lot of people is like my worst nightmare.
Try now your pull again.
Let's try that. Git pull. Okay, excellent. So let's just make sure that the translate API is in my pom.xml. Cat, or we'll do cat pom.xml grep. Yes. Okay, good. So let's actually deploy this. So Maven deploy. Unless I forgot something, no, but we'll skip test. Was that? Oops, oh, thank you. Come on, baby. Excellent. So one other really cool thing about this machine not being my development machine is that it's actually a GC instance on Google Cloud with really fast networking, 8 cores and 30 gigs of RAM. So it's going to push this to GCR a lot faster than I would have done if I'd done it on my laptop over Wi-Fi. Let's see how fast it does it. It used to be like 15 or 16 seconds. Yeah, so 31 seconds. That's around like 10 times faster than when I do this on my local machine. So what I could also do, by the way, which is really cool, and part of that story that I was talking earlier, which is that the individual building blocks of App Engine Flex are no longer this monolithic piece. the ability to build a Docker file from the cloud is something that we expose as a separate service that doesn't need to be used with App Engine Flex. Really easy way to do that is to, oh, yeah. Whoa. Okay, it's the zoom level that I think is screwing up my shell. So this is what it would look like. Gcloud container build submit dash tag, right? You just all you need is a directory. Yeah, all you need is basically a directory with your Docker file and your jar, and you tell Gcloud that you want a Gcloud container build with the tag that you want the registry to the tag you want to use to push to the registry, and that'll all happen in the cloud for you. So no longer do you need a local Docker install on your laptop or on your Windows machine, which is pretty cool. All right, so we've pushed this this code to Kubernetes, right? And let's take a look. Is it really there? So here's, no, this is a data store. Here's your container registry. So this is 2 minutes ago, V5 on. Did I not change the version to V? Oh, damn it. Okay, this was an important step because if I don't change the version to version 6, V5.9 is actually a version that I've pushed to before. So I have to change it real quick because otherwise when I bring this up in Kubernetes, it's actually going to use the old push that I have that might not have this code. So let me just do that real quick, 6.0, and commit that. So, and actually, let's change something else. Change the demo controller. Should say report 6.0. Update version to 6. Commit and push. Fortunately, we've got our super fast build machine to actually recreate this container, so it's not going to slow us down too much. Let's go back here. Actually, first we want to git pull. And then let's redeploy. So while that's happening, what are we going to do? Well, we can't do much because we need the image to actually start Kubernetes, and that's what I want to show you next. Let's see how long this takes. And let me have a sip of water. How are we doing for time, by the way? All right, I got to speed up. OK, so 24 seconds. So now, let's go back to container registry. And v6.0 is there. So how do I actually run this? All I have to do is, I'm going to skip typing because we're slow on time. And kube control run. I want to change the version to 6. So if you guys are familiar with kubectl or kubecontrol or whatever you call it, this is a command that you actually target your cluster with an image with. I'm going to go ahead and start that. The deployment's been created, but this is not App Engine Flex. This is Kubernetes. So now there's still some extra steps that I need to take so that people can actually hit this service from external IPs. So what I'm going to do is create a service by expose a deployment. So this is the deployment. This is a kubectl expose command, which creates a load balancer that external IPs can come through. We'll go ahead and start that. Now that takes a little time, so let's actually watch it. Kubectl service. So we can see here as the internal cluster IP that I wouldn't be able to hit from my machine. This is the name of the service, demo app, right here. And we're provisioning an external IP, which takes on the order of a minute or so. Hopefully no more than a minute, because we're short on time. Mhm.
What's IPv6 support like
On
in Kubernetes?
On Kubernetes, I don't actually know the answer to that question. Does anybody in this room know? I guess not. Well, I'm at least in good company. Okay, so we've got an IP. Let's check it out. This better work. What is going on, man? Come on, baby.
Not supported.
Not supported. Well, let's just check the pods real quick. Image pull back off? I don't even know what that means. Image pull back off.
You can pull the image and usually like if it's gonna do it for like 10 times, it's sort of exponentially backing off and so you can do the latest one.
Did I give the, oh, you know I did. Look, check it out. You see this? You can't see my cursor. This is not the right version. It should be v6.0.
Yeah, I
I was
noticed.
wondering about that.
Oh, thank you. Now you tell me you're wondering. Okay. There we go. Oh, I have to edit the deployment. Let me go edit, deploying demo app, v5, v6, of course. I've practiced this too many times. Okay. There we go. So what did I just do? I actually, really cool feature of Kubernetes, went and edited the configuration live. When Kubernetes sees that I've respec'd the service, it'll bring down the pods and bring up new pods with the version that I want, right? So if I go pods, here is creating the container. Let's actually scale this up real quick. Because by default, when I create a GKE cluster, it creates a cluster with 3 nodes. I should at least have 3 replicas, right? Let me go ahead and do that. I wonder if I can do that while it's restoring the cluster. I guess so. Here we go. And we've got already a running instance. Let's see if we can actually get that to serve. Yeah, there we go. Fantastic. So, hello, hola? Wait, no, that's what is it called? Visit hola? And we get a Spanish answer, right? So that's pretty great. And we're running out of time, so I'm going to skip a really, well, I'll show you really quick that the App Engine app that we had is also serving here because sometimes you need this, right, when you're using Kubernetes, but sometimes really all you need is this. And that's when you want to use App Engine Flexible Environment. So here we have App Engine Flex. Let me refresh. And we can see that this version 6.0 was deployed. But you might remember when I did deploy it that I hadn't made the version change in the label. So if I actually go and hit that endpoint, it'll say v5.9. But I think if we actually do visit, I don't know very many languages. Guten Tag? That sounds like a, is that spelt correctly? Yeah.
It needs to be separate words.
Well, it gave me some kind of translation. I don't know what language that is.
I can tell you that.
Okay. So remind me, what was I doing? Okay, I was showing you the scale. App Engine. Here we go. Really nice part about, like back in the day, when I did a deployment with a new version of our code to the servers, I just did a deployment. We had downtime, right? Maybe it was during the Saturday maintenance window that a lot of companies used to do and still do, but isn't really the way to do things today. And if there was an issue, it was an issue for everybody on the new version, and then we had to roll back, right? App Engine Flex and Standard provides the idea of versions which let you do really cool things like, okay, I've deployed version 6, but I didn't promote it, which means that I'm not sending all the traffic there. So what I'm going to do is actually split the traffic. Let's send 12% of traffic over, right? And that means that 12% of the people that are coming in are going to be on 6. I'm probably not going to hit it, so I'm not going to bother. But let's go ahead and actually move everybody over to this new version. Migrate. A really, really useful thing that I'm going to do as fast as possible with App Engine Flex is that with Kubernetes, I don't even know how to scale. Like, I know how to manually scale up, but I don't know how to figure out what's going on with my service, know that there's an issue, and start scaling up. With App Engine Flex, it's really straightforward. I have an endpoint here. We'll call it, let's just go to Java Tools, DevVox, because all my traffic is going here now. Appspot.com, slow. I have this endpoint which is really hard on the CPU, right? It spins over the current time, generates a hash, and looks for one that starts with 007, which apparently is what Bitcoin does. That's what I'm told. So really what I want to do is I'm going to generate a bunch of load against that using Apache Bench. Let's go ahead and start that. And you have to be patient because that's 10,000 requests, 20 at a time, hitting the back end. And while I do that, let's talk about another endpoint, right? Real quick. Back to Kubernetes. We'll go, I think it was called Hello Developers. Let me zoom in. All right. Do you see anything wrong with this endpoint? Correct. This is not Firefox. Although that's a great browser, I'm actually using Chrome, so something is wrong with my code in production. And this is on the Kubernetes cluster, right? So I spent plenty of time in my days working on managed infrastructure, self-managed infrastructure, trying to figure out what was wrong in production because I couldn't actually reproduce the issue on my local machine. This isn't actually a really good example of that, but let's actually see how the Cloud Debugger can help me solve this problem, right? So the first thing I want to do is actually look at my code. So this is the endpoint. It looks at the user agent, checks if it's Mozilla, and responds Firefox. So that actually makes a lot of sense, right? So let's go to the Cloud Debugger. Select Debug. And here we can pick our target. These are the App Engine Flex instances that are running. But here I'm going to pick the Kubernetes instance. So this is interesting. It's actually looking at my current code and seeing that the version doesn't match the version that's in the deployment. Oh, yeah, I'm sorry. Right? So that's really cool because it means that instead of attaching a debugger to code that is not the code in my current workspace or slightly different, where I'm setting breakpoints and when they get hit, the values don't make any sense, I'm actually making sure that the code matches the actual breakpoint. So let's go ahead and attach to that. And let's set a breakpoint. Hopefully it'll stick. The check marks usually means that the back end has received the breakpoint, set it on all your instances, and confirm that this is a valid breakpoint. Now we have 3 instances running, right? So I can't guarantee which one is actually going to serve this request. But if I actually hit it, come on, demo gods. This is the endpoint. So that's, if you look at the code, the only place where Firefox is set is at this line. So I'm assuming this line had to actually execute. Why? This is, let's see. Am I connected to the right? Let me try making sure that I actually connected to the right version and not to App Engine Flex instead. We'll stop listening. Go back. Okay, that's what I wanted.
You attached to 5.764, right?
Was that what happened? So if I set this here, let's try one more time. Da-da-dun, come on, baby. Yay, a new snapshot was received, right? Now I click on that, we're going to retrieve the data from the database and actually tell you what was in the request. And you can see the user agent right here. And the user agent for my Chrome browser, let me zoom in, turns out it starts with Mozilla, right? And that's because browsers are whack, and the web is whack, and I'm sorry if you work in the web. So that's pretty great, but you must be wondering, well, how the hell does that work, right? Because I can't set a breakpoint in production because that would affect user traffic, right? The fact of the matter is our agent stops the thread of execution at the line you select, captures all the state, and then lets it continue. And it's extremely inexpensive. We use this in production at Google, and it doesn't really affect the service in any way at all. Also, one thing that we do is we only capture one sample, right? The first time this happens, we'll capture it, and then we'll disable that breakpoint so we don't interrupt any other traffic. One thing that I've got 7 minutes left. I wanted to, the other thing, let's go back to App Engine Flex, which we just hammered with a bunch of Bitcoin mining stuff. Let's have a look over here and see, we've got the instances. We've got, look, 20 instances of our service running. That's the default max instances that you can configure. By default, it's 20. You can make it higher. There are App Engine Flex deployments that scale to the many thousands of instances. Now let's go back. Really cool thing that I really like to show people because it fits people's workflow really well, and it matches the use case a lot better than a traditional debugging session where you kind of enter and exit. Let's imagine that I'm actually making changes to my code, right? Maybe I'm working on version 6.7, right? And I'm changing the translations, and just maybe adding some logging, logger.info, blah, blah, right? And now I found out that I have actually this bug in production. When I want to connect, so zooming in, you've seen this, right? We make the code match the version, so we see we're back on v6.0, the logging statement is gone. But the odds are, if this is a hard to reproduce bug, it doesn't happen within the time that you actually set that snapshot in the session. So you want to go back to work, right? So we've reset the snapshot, and I'm going to stop. And instead of telling it to stop listening, I'm going to tell it to continue listening. So we've stashed your changes. We've restored them. So your code is back to where it was, version 6.7. You've got your logger.info, blah, blah, blah. You go back to work. Maybe a week later, somebody triggers this bug. What happens? You get notified in the IDE, and you can continue your session. Code goes back to the version that's in production, and you can actually inspect the state. It's pretty wild.
Can you actually step through?
No, unfortunately, you can't. One way that I've seen people actually try to do this is setting tons of snapshots, like one after the other, which you can do. It works. And they're working on improving the experience so that we can support more of these kind of use cases.
I mean, you should be able to, on some level, step further, right? Because it depends on what you capture. I mean, you have the request, you could capture the whole state.
Yeah, it's pretty tricky, right? Like if you're talking about kind of like evaluating the code in your local environment with a state that you had, and the code might be doing RPCs and things like that. So yeah. So I want to kind of, I went way over, so I have to give a shout out to something that I was going to do in my demo, which is this dynamic logging feature, which allows you to actually dynamically add logging statements to your production environment services without actually having to add logging statements and redeploy them. It's a real time saver. And obviously you can like, all your instances are going to be logging all of those statements all the time, and you can turn them on and off, right? There's a command line, which is, log points. So you can basically see here that I don't have any. But you can use the gcloud CLI to actually do this, right? And create a login statement. I wonder if I have a log points create in my history somewhere.
We have to start in like 2 minutes.
Okay, all right. Let's actually call it quits and go to questions. So we're the tools, libraries, and runtimes Java team for Google Cloud Platform. We're working really hard on making your life easier on our platform. We are totally open source. We're on GitHub. We're on Slack. Come and find us and file issues and feature requests. If you guys want to if anyone wants to take a picture, go ahead now. I can leave it for a second or not. It's fine. And let's start questions, actually.
They got it set up.
Oh, okay. All right. In that case, no questions. I'm sorry.
Questions in the hall.
Okay. I'll be right outside for the next 5 minutes. Thanks.